this diagram in hand. Initially, the total system is in equilibrium. So this is Fs. The thread QS is cut. Find the acceleration of A and the normal contact force between A and B immediately after the thread is cut. Okay, let's see that any forces that are here, it will be mg sine theta or 3mg sine. Let it, no problem. One by one, we'll take it. 2mg, there'll be a normal contact N1. This N1. Mg cos theta. Here it will be this normal contact, let be into, which may not be useful. Let's have that one. A spring is elongated or compressed. Let's see that. Any equation will get it. Whether it's elongated, compressed, I too don't know. If I get x naught negative, I'll change it. Okay, we have value of Fs. So what is Fs is equal to? This Fs should be equal to mg plus n1. And I'll start with the block. N1 plus kx naught minus 2mg equal to 0. So we have to calculate somehow N1, then we can say about the spring. There's the equation 1, you write it. Then along the incline on the block A, Fs minus Fs value root 2 mg. Theta 45 degrees. mg, so N1 equal to mg. If N1 equal to mg, so let me substitute this in equation 2 in 1. So N1 plus kx naught, N1 is mg, no? Okay, fine. So this is the, so what is the status? Spring is elongated. Simple idea based spring elongated compressed. What happens? You assume any one and get into the problem. Okay, now what I do is I'm going to cut this spring. When I cut this spring, find the acceleration of A and the normal contact force between A and B immediately after the thread is cut. When I cut this spring, what will happen to the spring force? Should not change. No, spring force cannot change suddenly in most of the numericals, but in some numericals, even this can also change. Tomorrow I'll discuss some numericals where spring force also will change. Because anyway, it is connected to between rigid supports, so not possible. Tomorrow, some problems are there where spring force will change. But let me talk generally. Sudden change in spring force, not possible. So spring force will remain as it is. So what is our entire discussion? You make Fs 0, then discuss the problem. Okay, this is the, so initial spring force, let me keep as it is. Yeah, I'll this equation, okay, I just wrote it to get the value of N1. You can manage by any method. Let me Show complete diagram. Okay, let's get into the next part of the problem. So this will be M to M is asking what will be these values. This will be N, this will be N. To mg A2, I'll write it here. So again, a pseudo force to MA2. So this should be the same set of formula, no? What we earlier discussed. So here mg plus n1 mg plus n1 sine theta should be g sine theta, no? Equal to, I feel, yeah. MA2, I'll write it. Okay, we don't know this. I'll write N1 dash. Now it is a new thing. It is. Then again, the forces that are acting, N1 dash plus Kx naught plus 2ma2 sine theta minus 2mg equal to 0. A2 and N1 dash, A2 and N1 dash are the unknown things. Solving that, we'll get the required answer. Kx naught value, what we know is value is mg, Kx naught. So spring force will not change. So this has to be taken into picture. Anybody value?
0.
A2, huh?
Normal contact 0.
Normal contact N1 dash, you mean to say?
Yes, sir.
This will be 0. A2 then?
G by root 2.
G by root 2.